All right. So for your warm up, you have the months of the year. So January is what month of the year? The first month. So what you should be plugging in for January is 1. February should be 2. March is 3, so on and so forth. Okay, so when you're plugging that into list 1, January is 1, February is 2, so on and so forth there. All the way up to 8 because that was your August value. Okay, and then from there, after you're entering in the data, you're going to find linreg, quadreg, cubic reg, and quart reg. You should have found that quart reg had the highest value for r squared at 0.972. How'd that go? Finding all the r squareds. Okay, something you will have to know how to do tomorrow is turn your diagnostic on. Because you're going to clear your calculator, and there's 2 ways to turn it on. So you can either go to your stat diagnostics, or you can go to the catalog. I have the directions to finding that in your Google Classroom. So I have a whole document that shows you how to do all those calculator things. So if you need some extra practice tonight, I would do some sample problems where you're punching those in. So once you decide that it's the quart reg, you're going to take your values. We're always going to be rounding these to the nearest thousandth. So you can go ahead and check that. You don't know how to yeah, let's go over that. Okay, so once you have your function, okay, then it's asking you to find what happens the following year is what it said, right? So in August it was 8, so the next month, or sorry, not the next year, the next month would be 9. And then for your exact value, you should get 43 hours. So I've shown you how to do your exact value. I want you to know how to do your exact value. If you just plugged in 9, you get the 44, which is why I want you to do the exact one, okay? Because they are a little bit different. And I just want you to follow your normal rounding rules, okay? So the normal rounding rules is if it's 0.4 or below, you're going to keep it. And then if it's 0.5 or above, you're going to round up. So did you guys get like 43.1 when you did that? Okay, great. Yeah.
Did it say that we're supposed to round to the nearest hour?
No, I told you. I just did it. I said just round these to the nearest thousandth, and then this one just round to the nearest whole number. And then your quiz will say in the directions round to the nearest whatever it is. Hour. I can't remember what it was on our review, but we'll look at that too. Okay, and then for the stat plot, once you have this in your calculator, okay, once you have your data in there, remember, you just have to turn your plot on. So you just have to highlight that, okay, and then once you have this in your y equals, if you graph it, you should be able to see both of those. All right. And then, do you guys remember how to get your equation in there? You got to go to quart reg. So you have to go to stat. You have to go to quart reg. And then, if you have a calculator like mine, this is where you do vars. Go over to y vars, enter, enter. Then you can go to calculate. Then go back to y equals, and it should be there. If you do not have this screen, then it will just say quart reg on your calculator. Don't press enter. Then you do the vars, y vars, enter, enter. Okay. All right, and then for your stat plot, this is just something that you're going to have on your calculator. I'm not going to make you draw a representation of it. The reason why we've been practicing this is eventually we're going to talk about a different type of exponential regression where you do have to look at the graphs to decide between two of them that are very, very close. Okay, so that's why I wanted you to have just some baseline information. Okay, but the stat plot isn't something that you're going to have to show me on your test, okay? All right, let's check the first part of our review, and then if you guys need some help with that, I can come around and help you. All right, so let's start with the no calculator portion, because that was on the front side. On your quiz tomorrow, you are going to do the calculator portion first, just FYI. All right, so it says describe the end behavior by filling in the blank spaces, then state the degree and leading coefficient of each polynomial, state the domain and range and interval notation for part A only. So you didn't have to do the domain and range for part B. Okay, so your end behavior, based on this, if you have an odd degree, the ends go in opposite directions. If you have a positive coefficient, it goes up on the right. So as x goes to the right, f of x is going up. And then as x goes to the left, f of x is going down. Okay, did you put the right one first? Is that what you're going to ask me? I was going to say that's okay. So if you put positive, positive, negative, negative, I would mark that correctly. Yeah. So it's based on your leading coefficient and your degree. So if this is positive, then on the right side, it has to go up. So wherever x is positive, f of x has to be positive in this case. And then if it's odd, the ends are going in opposite directions. So whatever you put for this one, here you'll do the opposite. So I always fill in the right one first, like if x goes to positive, which is why I do some like that part first. But these should always have one negative and one positive. These are going to depend on if it's odd and then if it's positive or negative. Yep, so if it's odd, these two f of x's should be going different places. And if it's even, they'll be going to the same place. It just depends on if it's positive coefficient, they'll go to positive, and negative, they'll go to negative. Mm-hmm.
Like, since I flipped the entire thing,
yeah.
Is one of them more accurate?
No. No. Yeah. It's just generally you start with the negative because it comes first, like on the x-axis, but it's not wrong to say it the other way. Okay, and then your degree is 5, your leading coefficient is 2/5. Your domain and range are both all real numbers. Remember, the range is all real numbers when you have an odd degree. So when you have an even degree is when the range is not all real numbers. I put the other two ranges that you'll see on there. If it's above 0 or if it's below 0. Okay, so those are a few of them that we practiced. If there's a positive leading coefficient, then it goes from 0 to infinity. If there's a negative leading coefficient, it goes from negative infinity to 0. So you do have both those cases in your notes. That is something that you practiced if you did your homework. But I don't want you to think like, oh, she gave us an odd degree here, so yeah, that's what it's going to be. No, that's not necessarily the case. You have to make sure you know all your cases. So know what happens if the degree's even and when it's odd. Okay? And then for part B, your degree was even, so this was not written in standard form. Your degree is always the highest exponent. If it's even, you know f of x is going to the same place. And then because this is a negative leading coefficient, we know they're both going down on the left and the right. The negative tells you that you're going down on the right because they're the same. It's going to go down on the left as well. So the degree is always the highest exponent. It might not be the first one. It might not be in standard form. So make sure you can pick out your degree and your leading coefficient. Any questions for me on number 1? You can tell there's a lot of stuff with your degree and your leading coefficient here. So you had to write 2 examples of expressions that are polynomials. You can have x to the 5th minus 3x squared plus 1, 1/2 x to the 5th minus 6x to the 6th. Okay, and then again, this just says polynomials. So you could have a polynomial with 2 variables. Like if you have, okay, I said 2ab squared minus ab, that's still a polynomial. Okay, what you have to watch out for is what I asked you to write down in part B.
Would I be able to like, I didn't do this, but would I be able to like the sum of a plus b squared? The sum of a and b squared, in parentheses.
Oh, yeah, yes, the quantity a plus b to the power 2, yes, yes, yep, that's fine. Okay, and then for B, write 2 examples of expressions that are not polynomials and make sure you explain that they're not. So these are the 2 main cases that you have to be able to explain. So one is when you have a negative exponent. So you can just say it's not a polynomial because you can't have a negative exponent. Or I saw some of you like saying the variable in the denominator, but if you do that, tell me what's in the denominator. So not a polynomial because you can't have an x squared variable in the denominator, or you can simply say not a polynomial because can't have a negative exponent. So either one of those are fine. Okay, the other type is you can't have a variable under the radical. So I want you to carefully look at your explanation. Did you mention that you can't have a variable under the radical? Or did you accidentally say that you can't have a radical? Because you can have a radical, right? You could have the square root of 4. The square root of 4 is just what? 2. That's fine. Okay, you could even have a square root of 3. That's just a number. The main thing you have to have here is that you can't have that variable under the radical. So make sure that you understand that some of these are going to require some explanations. Okay, and we have to be able to write those out in words and not just symbols. Okay, 3, when it says real zeros, that means find the x-intercepts, and there are 5 in that graph. Okay, and then for number 4, identify the degree and leading coefficient of the functions below, and then explain how you know using key terms and evidence. Nope. So there's 1, 2, 3, 4, 5. So I kind of marked them with slashes. So there's a couple that are right next to each other, like here and here are the 1 and 2. There's the 3, and then this is the 4 and the 5. This one goes up above a little bit. Okay, and then for number 4, I'm going to show you my answer, and then I've underlined the key terms that I'm looking for. So for number 4, you need to mention it's an even degree because the ends are going in the same direction. So even degree, ends are going in the same direction. Okay, and then the leading coefficient is a negative because the graph falls on the right side. You could say it goes down on the right side, but make sure you communicate that the leading coefficient is based on what's happening on the right. Okay, so it's negative because it falls on the right. Okay, and then for B, the function has an odd degree because the ends go in opposite directions. So odd degree, ends are going in opposite directions. The leading coefficient is positive because the graph rises on the right. Okay, so make sure you understand how the even and odd degree affect the ends and how the leading coefficient, whether it's positive or negative, how that affects one end in particular.
For B, I said the degree odd because both sides go in both directions and are
Well, I really do want you to associate the degree with where it's going, not the range. But will you say what you said again? You said both. You said they go in both directions.
Yeah.
That should be okay. I'd rather have you be say like one up, one down. Yeah. Yep. And then on the back side, you guys had a multiple choice one that you had to do an explanation for. Okay, so once you have this, okay, you're going to say, or what I did here is I wrote where these went. So this is saying as X is going to the left, the graph is going down. As it's going to the right, it is going up. So based on those two things, I knew that the ends went in opposite directions, so I had to have an odd degree. So I looked at the degree of all of these, and if it was even, I crossed it off. That left me with these two, but then I also had to check to make sure it was a positive leading coefficient because it went up on the right. Both of those went up on the right, so it is both B and D. Okay, now really I wrote this out twice. You only need that out once. But you need to say something about the odd degrees happens because the ends are going in opposite directions, and then the leading coefficient is positive because on the right side it's going up. Okay, and then for number 6, you're performing the indicated operations, write them in standard form. Okay, so the first two in standard form, there's only one variable, so that should be quick. Okay, and then how did A and B go? And then those are only one variable, so standard form should be pretty straightforward, but some of the next ones, you might have some questions about standard form. Okay, so for C, you're distributing. This is standard form. You should have it written just like this. So when you have two variables in standard form, you look at these alphabetically. So you have x to the 6th power, and x comes before y, and then x to the 1st power. You always look at that first one, and it should go in decreasing order for x. So x is higher here, so it's going to go first. Okay, so same thing with part D. So for part D, alphabetically, what comes first, A or B? A. So anything with A in it is going to go first. So this is A to the 2nd power. This has A to the 1st power. This doesn't have an A in it. So it should go A squared, A to the 1st, no A. Okay, so did some of you like flip those two around? Okay, so this is really going to be exactly what you get when you FOIL. So it should go in that order, like the same order when you do first, outer, inner, last. Okay. All right, and then the next two only have one variable. Remember, this is your no calculator section. I think the highest multiplication you had to do was 21 times 6. So you could do it like this old school style, or really, what's 20 times 6? 120, and then 1 times 6 is 6, so you just add them together. 120 plus 6. All right, and then for F, some big numbers there, some bigger exponents. And again, you can do this whatever way you like. So if you like writing them out fully and then combining them, that's fine. I like lining mine up. That's okay. So whichever one of those methods you like is fine. And how did those two go? Good. You really just have to be careful when you're switching between multiplying and adding. Okay, now we're going to go to the calculator section. So on your calculator section, the first thing you're going to find is your relative maxima and your relative minima. I noticed some of you did not write this in the proper form. So when you're writing this, it says to draw a rough sketch of the image in the space below. So you can just draw a rough sketch. You don't have to put the numbers on there. I did because it helps me. And then it says find the relative max or min and state the x coordinates at which they occur. The max or the min is the y coordinate. So that's why you have to write it like this. You're acknowledging that the maximum or minimum is the y at whatever your x equals. So all of them should be written in this form. Now you only had one minima. Okay, and if you did get this wrong, please go ahead and graph this right now and let's see if we can fix that in your calculator and make sure we can find those. Okay, and then there were two relative maxima. You can see mine on my sketch right here and right here. So let's make sure that we rounded those correctly. And then if you need to write a note to make sure you have that proper form, okay, because I do give you points for writing it in proper form. All right, and then we are finding the zeros in graph 2. So in graph 2, your zeros are negative 1.926 and negative 0.809. Again, you can see that we're rounding these to the nearest thousandth. So I'm going to keep those the same on your quiz since that's what we've been working on. And then you had to just fill in the y values. Now, when you look at your graph, make sure that you have curves. So you cannot have like this. You don't want any sharp edges. Those are no. Okay, when you connect it, you want to make sure that you're weaving it through those. So remember when we were graphing these, like on our homework, I said, oh, make sure that you like curve it like this first. And then you could do this curve. And then you can do this curve. And then you can connect them together. Okay, so make sure that you have those curves in between there. All right, and then we're going to check our equation. Okay, so for these, we want to make sure we can see our r squared values. You're always looking for which r squared value is closest to what? 1. So whichever one is closest to 1, so it was court reg. You don't have to write this out. I was just showing you how we rounded all of these in case you were off on any of them. Okay, and then we're going to do the y bars again. And then you guys should have this exact answer, this 14,317. That is your exact value. And then if they give you the 1, 2, 3, that's what you're going to enter in. Shall we practice entering those in? So we're ready for tomorrow? Okay, so the first thing we'll do is we'll go to our mode and we'll make sure that the stat diagnostics, because it'll say this, it'll say off. We're going to turn it to on. Okay, and then once you have that, you're going to go to stat, enter. And if you want to clear them out, you can do clear, enter, and you have 1, 2, 3, 4, 5, 6, 7, 8, 9. Be careful when you're entering things in because this is where things can go awry. And it might not even be that noticeable. All right, and then if you ever have like an extra thing that you need to delete, like if you put that in there accidentally, you can just hit delete if it's just one entry. Okay, and then we're going to go to stat, and then we're going to go to court reg. And then this is where you can do your vars, Y vars, enter, calculate. No, because we've had some that were cubic, but I know a lot of them have been quart reg. It's whatever you get here. So if you have x to the fourth, if you've decided that quart reg is the right one, that's what you're going to use. And now that should be in your y equals. Okay, and if you go to zoom and then 9, you should have a nice little graph there. So if you go to zoom, so if you go to y equals, turn your plot on. It's already in your y equals. Okay, so you're just making sure that your graph is a good fit for the data. And then we're going to go to our table. And our table says find out what happens the following year to the nearest book. Okay, so I'm going to start at 0. I'm going to go by ones. Sorry, I was doing something else with another class, which is why it says that. Okay, and then remember you have to highlight this to see what it is. So 14,317, that is our value, 14,317.